Hello guys, myself Kapil Kumbhar. I am a third year student of civil engineering from MIT Academy of Engineering, IND. So today's presentation topic is bridges. So firstly, what is the bridge? Bridges connect points or obstacles enabling travel and transport. Design evolved from simple stone structure to modern engineering marvels. Today's bridges blend aesthetic strength and functionality, ensuring the safe passage worldwide. The bridges the bridges are constructed over a river to connect the two points which are not accessible by the normal roads, then which enables the easy way to the transport. When the bridges are introduced in the worldwide, firstly they are formed by the simple stone structure. But nowadays, due to modern engineering, there are marvelous bridges which can be seen worldwide. It is not mandatory that bridges are only built over the water source. It can be built over a train, railway track, or roads also to prevent the over traffic on the road. Then on next slide, it is a typical cross section of the bridge. Here you can see the component of bridges, that is approach slab, deck slab, then curb, expansion joints, handrails. The main component of the bridges are the deck slab, then abutment, piers, then these bearings. So one by one we will discuss about the component of bridges. Firstly, deck slab. So deck slab is nothing but the surface over which the cars or vehicles run or transport. Then another is a curb. Curb is uh, so we will discuss about curb. So the portion which is slightly overhead on the bridge is called as a curb. Then expansion joint. Expansion joint are provided if the span of the bridge is more. It is provided to tackle the problems which occur due to long span of the bridges. If the expansion joints are not provided, the bridge will be subjected to high loading and then it is subjected to fail. Then handrails are the supportive section. Then after that, abutment and pier. The main difference between abutment and pier are the abutment are the structure which is constructed at the end and at the start of the bridges, and the piers are the intermediate support. Then back wall is used for backfilling to support the backfill of the bridges. After that, foundation is a main structure which is which is which transfer the load of the bridge to the soil strata. Then next, classification and types of bridges. So basically, bridges are classified in based on three parameters. First is structure based, then material based, and common types. In structure based, there are three types of bridges. First is beam bridges, second one is arch bridges, and suspension bridges. Then material based, steel, concrete, and timber. Mostly the bridges are built nowadays are steel and concrete. We Nowadays it is difficult to find the timber bridges, but it can be seen in the village area. Then other common types of bridges. First is slab bridges, then girders, truss, cable stay bridges and suspension bridges. For cable stay bridge, there is a big example of Juari Bridge at Goa, North Goa. The Juari Bridge connects North Goa to the South Goa, and it is fully cable stay bridge. The construction of this bridge is completed in 2024, and which is inaugurated by Mr. Nitin Gadkari sir. Then on next slide we will discuss about structure based type of bridges. Here you can see the types of bridges based on the structure. So first is a beam bridge. Beam bridge consisting of the beam which is supported over abutment and pier. The beam is the beam act as a The beam acts as a roadway for the vehicle to transport from one place to another place. Then suspension bridge. In suspension bridge, the bridge is connected with the suspension wires. As you can see in the figure, these are the suspension wires, and the bridge is totally connected by these suspension cables. Then arch bridge. Arch bridge is basically named due to this arch which is constructed below the deck slab of the bridge. It can be seen in the Italy, and it is the arch bridge is provided to pass the boats through under the bridge. Then cable stayed bridge. In cable stayed bridge, the cables are used to hold the bridge. The tension is induced in these cables to hold the bridge in a good way. Then tied arch bridge, cantilever bridge. Cantilever bridge is consisting of a cantilever portion on one or both sides of the bridge. Then truss bridge and bascule bridge. Bascule bridge is nothing but the automated bridge. Then bridge component, as we discussed on previous slide, it is bridge components are classified in main two structures. First is a superstructure and another is a substructure. Superstructure means above the ground level. Structure which is constructed above the ground level is called a superstructure, and substructure means below the ground level. Superstructure includes deck girders and trusses that carry load over the span, and substructure contains piers, abutment, and foundation support. The superstructure. Substructure transfer the load from superstructure to the subsoil strata. Then additional elements are bearing, expansion joint, and railing ensure flexibility and safety. The function of providing bearing. So consider this is one deck slab and this is the pier of the bridge. The bearings are provided in this location. Bearings are provided to carry the load coming from the vehicles and transferred to the pier. Uh, Bearing is also provided to carry the movement which is coming from the deck. Then on next slide, what is economical span? So the concept of economical span is nothing but the cost and structural efficiency. In minimum cost, the bridge should give the maximum efficiency. It is nothing but the economical span. Then the factors which is considered in economical spans are material cost, foundation condition, and construction technique. Then optimization, span length optimized to reduce overall construction and maintenance cost. The economical span concept is roll around the roll around the cost of construction and efficiency of that bridge. Then example is cost analysis for various span over river crossing. it demonstrates the impacts. On the next, hydraulic consideration. Afflux. Afflux is nothing but backwater rise caused by bridge constriction affect flow level. So the concept of afflux is nothing but, suppose this is a river, and we construct a bridge on the when we construct a dam on the river, the water the water behind that dam is increases over a long length of the over a long length. So this water which is behind the dam is called as a backwater, and the rise in this backwater is nothing but afflux. Then high flood level. The critical design parameter recorded via hydrological data is nothing but high flood level. High flood level is nothing but highest level of the water. Then scour depth. Scour depth is nothing but the erosion around piers calculated for sector. Scour depth is nothing but, suppose this is a pier and this is underwater, this is the water. Scour is nothing but due to the action of this water which is coming on that pier, the erosion of this surface of pier is done, and the depth at which this erosion happen is called as scour depth. So the mitigation for scour depth is, the first is a riprap, second is cut-off wall, and third is spur dikes. Riprap is nothing but providing the stones in in triangular manner at the abutment to reduce the scouring action and to enhance the uh, load capacity of that abutment or to support the abutment. Then cutoff walls is nothing but the vertical walls provided to reduce the scouring action of the pier or abutment. Then, loads on the bridges and IRC specification. So first is the dead load, live load, environmental load, and IRC load. Dead load is nothing but weight of structure itself, always acting downward. Live load is nothing but the vehicular load, pedestrian load, and railway load that vary over time. Environmental load consists of wind, seismic temperature changes, and snow load consideration. There is some IRC standards which define the standardized load cases and combination of load cases which is used to design the bridges in India. Then next is the failure of bridges in India. Causes of failure of bridges in India. First is scour and hydraulic action. As you seen in this figure, which is riverbed mining India 2021. These are the images from 2021 from the monsoon season. Actually, here you can see the scouring of this part is done due to the high pressure of the water. Then here you can see the whole pier is collapsed due to scouring action. Then here also one pier is subjected to the scouring action. After that, material corrosion. Material corrosion is it can happen due to less cover provided, or the uh, chemical effect on the steel or rebars of that structure, or also environmental effects. Then overloading. Due to overloading on the bridges, the bridge can be collapsed. For example, the bridge is designed for 100 kilonewton. The patch of bridge is designed for 100 kilonewton, and you provide 125 kilonewton over the bridge. The bridge will directly collapse. Then design flaw. Due to some human error or design error, the bridges may be failed. Then the conclusion. Bridges require balanced design covering structural loads and hydraulics. And sustainability, resilient and eco-friendly design is a key feature for infrastructure. And for the smooth traffic flow and without any accident, if you if you like to uh, if you like to keep the bridges in safe condition, you have to do maintenance on regular basis or on the periodic basis.